Right, the thing we have to look at is something called conservation of energy. And so what's that all about? Well, it goes back to Albert Einstein. He said that energy cannot be created nor destroyed. It can only be converted from one form to another. And what he means by that is in any situation there's a certain total amount of energy, and that won't change no matter what happens, but the type of energy may change. Like, for example, a light bulb has electrical energy and it turns it into light and heat energy, but the total amount of energy isn't changing there. And the situations you need to be aware of are looking at two kinds of energy. And the two that you know a little bit about are gravitational, I might change that colour, make it a bit darker. Gravitational potential energy we'll call EP, and kinetic energy we'll call EK. And remember, gravitational potential is due to your position where you are, and kinetic is due to the fact that you're moving, your motion. So we'll take this little cat and we're going to put it up in the tree. Okay. So while it's high up in the tree there, it will have a certain amount of potential energy. And remember, that's equal to the mass of the cat, gravity, strength of gravity, which is 10 in our case, and the height that it is above the ground, the height of the tree, or where it is in the tree. Now, perhaps that cat, I don't know, gets a fright and it starts falling out of the tree. As it's falling, it's losing potential energy because that height is getting less, but it's gaining another kind of energy, kinetic energy, because it's starting to speed up, it's starting to move as it falls. So as it falls, it loses EP and it gains EK. Keeps falling, and just before it hits the ground, it'll be traveling at top speed. It's now lost all of its EP because H is basically 0, and it's gained kinetic energy. And what we can say is that let's put it in the middle here, the loss in EP equals the gain in EK. That means if we know how much potential energy it has when it's here, if we know the value, we can work out, or we know that that value, that number will be the same as the kinetic energy it gains here, because all that potential has gone to kinetic. And it allows us to work things out, like perhaps how quickly the cat's moving. Another situation using the same two kinds of energy are something like where we take a ball and we throw it up into the air. So we've got a ball here, and you kick it up or throw it up into the air, and just as it leaves the ground, it'll be moving upwards, and it's still virtually, we'll call it 0 height. So it's got kinetic energy. Okay. As it rises, it will, as it goes up here, it will lose kinetic energy, but it will gain potential energy because it's starting to slow down, but it's gaining height. So the half mv squared is getting less, but the mgh, the h part, is getting bigger. At the very top of the height, just before it starts to come back down again, so at this point here, its upwards motion, its actual speed upwards is 0 just for that moment in time. So now it's got all EP and no EK. Again, this is useful because if we know how much kinetic energy you have here, that will be the same number up there. So perhaps if you know the values, you can use it to work out the height the ball goes to if you know its mass. And we'll look at the calculations in another video.